Okay? So, when you did experiment on proteins, we did the following. So remember when we tested, when you used egg albumin, no? And then you tested that for San part yun? Let's go to page 75. So when you try to for protein denaturation, okay, you place them in boiling water, heated for 10 minutes with constant shaking. So, and then after cooling, you added 2 ml distilled water. So the filtrates you tested with the Burette reagent. So you're expecting to, you're going to have a blue-violet color to confirm the presence of proteins. Okay? So how many ml you used? We used 1 ml of the Burette solution. No drinking inside the laboratory. Okay? So, yun, sa Burette. As I've discussed also in the lecture, your protein can precipitate by heating. So the precipitate is what caused the precipitate to form. It's the denaturation of the protein. So the tertiary structure, the quaternary structure, the tertiary structure is destroyed. Okay? So mainly you still have the primary structure intact, but the main structure of the protein is destroyed. So when you cook an egg, the egg white becomes solid. You're basically turning it into a precipitate. Okay. So extreme heat will cause the protein to precipitate, as well as strong acids. So the pH is very low, so you destroy the H bonds in the protein. Okay, in our experiment, we only used 2 metal ions. What are the metal ions? Copper and silver ions. Okay, so copper sulfate and silver nitrate. Okay, so those details will come up in the exam, okay, for the lab. So that will be after your lecture exam next week. So 2 weeks from now, this will be covered by your lab exam. Okay. So it only works if your protein is polyanionic, meaning you need your protein to be negatively charged so that it will form a complex with a positively charged metal ion. Okay? Usually you add sodium hydroxide so that the protein will become negatively charged. Okay? Remember you have NH3 plus and O minus, right? So in neutral pH, you basically cancel each other out. But if you add sodium hydroxide, you remove the positive charge of the NH3, so that becomes NH2. So mainly you have negatively charged proteins. And when you add positively charged ions, like metal ions, so heavy metal ions like copper and silver, it will form an insoluble metalloprotein. Okay, so that forms the precipitate. So with a few drops of the heavy metal, so we used copper sulfate, and which is color blue. So that's why your precipitate was colored blue as well, because the copper sulfate mixed with that. And then you have silver nitrate, basically it's white, right? Use silver nitrate. Okay. So you form the precipitate. So with acidic reagent, we only had picric acid. Okay. We didn't have TCA or phosphotungstic acid, so we just have picric acid. So due to the direct union of the anionic group with the cationic groups of the proteins, these form in an acidic medium. You form a precipitate in an acidic environment, so opposite that of the metallic ions. In an acidic environment, you turn the protein into a polycationic molecule. So these compounds carry large negative charges which neutralize the positively charged protein to form an insoluble salt complex. So you form a precipitate as well. So the acidic reagents are therefore most effective in an acidic medium where proteins are positively charged. Okay, so at low pH, you have positively charged proteins. So as you increase the amount of picric acid, then you form the insoluble salt complex with protein. Okay, so you slowly add. This is for the. If you add, we didn't do this in the laboratory, but if you add sodium hydroxide, it will turn the medium into basic medium. Therefore, the precipitation will not occur as you increase the pH. Okay, so you want the environment to be acidic so that you form the precipitate with picric acid. Okay, so that's it. Easy lang. Wait, I'll be discussing another thing. Okay, so take note of the details, no? So we discussed this in the lecture naman. So you already know some parts of it. So the primary structure, secondary structure, tertiary, quaternary. So read on these details. I will get questions from that. You have to remember also, instead of a crucible, what did we use? We used a test tube only. Okay? Instead of a Bunsen burner, we used lighter lamp. Okay. Alcohol lamp. Okay? So you need to know how to prepare the egg white, the egg albumin solution, what metal ions we use. So you form a precipitate by the use of heat, heavy metals, etc., mineral acids, alkaloidal agents. Okay, so take note of that. That will come up in the exam. Okay, we go to acids. If you watch the acid, I discussed the Arrhenius, Bronsted acid, Bronsted base, and then in the discussion of buffers, I also discussed how to compute using the Henderson-Hasselbalch equation. So please watch that video. Okay, so take note of the details. So the important thing is the change in pH here, right? So what did you hindi pa pala to buffer. So here you have, for the pH paper, this is more accurate than the pH meter, no? So the pH meter is damaged. So you'd expect inaccurate results from that. You expect more accurate results using the pH paper. Okay? So for the fruit juices, what pH did you have? What pH? What value? Around 3, right? So it's around 3. Okay. Distilled water, it should be 7. Sodium hydroxide should be 13. Okay. What else? Coffee, around 6. What else? Soft drinks, around 3. Okay. So take note of those. You should be able to complete the tables like this. So even though, did you include this in the discussion, or so even if it's not included, you should try to solve these problems. Okay? So similar to the quiz that you did, okay, we had this type of quiz, diba? Filling up the table. Tapos yung number 3, calculate the pH of a mixture of 0.25 molar acetic acid and 0.1 molar sodium acetate. So what is how do you answer that? Okay, so I'll just solve this. Nandyan ba yung ano ko? Wait. Okay, so kumakanta na naman. So let's answer number 3, calculation of pH. Dapat kasama to kasi kinalculate niyo ba to? Letter D? Ganyan sinol? But this will be part of your exam, ha? Kasi ano. So for number 3, calculation D, number 3, no? Calculate the pH of 0.25 molar acetic acid and 0.1 sodium acetate. So you're given the concentration of, I'll just do a shortcut of acetic acid. So this is 0.25 molar. And your conjugate base, so it's basically the salt, sodium acetate, 0.1 molar. Okay, and the pKa is 4.76. Okay, so what formula will we use? What formula will we use? pH is equal to pKa plus log of the conjugate base over the acid. So in this case, pKa is 4.76 plus log of 0.1 over 0.25 molar. So what's the log? What's the answer? Log. Plug in nyo lang 0.1 divided by 0.25. 0.4? Dapat negative dapat.
Negative 0.30. 0.4. Negative.
So 4.76 plus anong value nito? Negative 0.39. So we can round that off. So magiging 4.36. Okay? So marami pang ano yun, may mga examples pa ako uh, dun sa uh, dun sa video na YouTube video. Okay? Okay, so let's go to the let's go to the buffer that we had, no? What buffer did we have? Let's go to experiment 2. Okay? So we discussed the concept of a conjugate acid and a conjugate base, right? A very good buffer system is one that includes the phosphate ion. H3PO4 will form H plus H2 PO4 2 minus. So this is the first dissociation constant. We have a certain pKa. I think it's 2. Can someone search for the phosphate pKa of the phosphate? No? Tapos H2PO4 2 minus will form H plus HPO4. Also this is negative 1, sorry. Negative 1, this is negative 1. So this is negative 2. So this is pKa 2. So pKa 1 is around 2 and this is around 7.1 or something. 7.2. Okay, so this is 7.2. This is 2.1, right? 2.2?
2.2. Round.
And then the last one, HPO4, will dissociate into H plus PO4 3 minus. So this is pKa. What's the value? 12.4. Okay. So how do you pick a buffer solution? No? So it has to do with the value of the pKa of the specific species that you want and what pH you want to have. Okay. So what pH do you want to have for a buffer? In your buffer should have pH that is equal to pKa plus or minus 1. Okay, so in the lab experiment, what is the value that you wanted? What value? What is the value of, di ba, ano yung hinalo natin? Kailangan mong mag-gain? Hinalo natin yung dalawang buffer, gusto nating nakasunod doon. 6.5. Okay? So, saan papatak ang plus or minus? Yung 6.5, saan papatak sa plus or minus ng tatlo? Saan? Dito, di ba? Kasi plus or minus, so 6.2 to 8.2. So, dito siya papasok. Kaya ang ginamit nating species. So yung counter ion nito is sodium H2PO4. Kaya yung isang buffer natin, yung monosodium. And then, yung isa, yung counter ion natin dun sa negative 2, Na2HPO4. So that's why we chose that buffer, no? So we used monosodium and disodium buffer because the pKa falls under this value, plus or minus the 6.5 that we want. So that's how we use the Henderson-Hasselbalch to know what type of pH you want, no? Pag hindi eksakto, dinatagdagan mo yun ng acids or bases, kaso hindi kasi accurate yung pH meter natin eh. So I've been trying to convince them to buy a new pH meter para maganda yung adjustment ng buffer. Kaya sinabi ko wag na lang tayo adjust. Okay? Do you have any questions? So klaro kung bakit yun ang pinili nating buffer system. Okay, so know the details dito. So, yung protein natin, protein acts as a buffer as well. So, yung egg albumin, it acts as a buffer kasi meron siyang NH3+, meron din siyang acid part. Kaya, pwede siyang magamit as a buffer. So, that's why, dito sa values na to, dapat alam nyo yung bawat test tube, no? Konti lang naman yung pag-aaralan sa lab, 3 experiments lang. So, dito sa test tube, alam niyo dapat kung ano nilagay nyo. So, the test tube 1 and 2, distilled, 3 and 4, yung egg albumin. So, you expect yung delta pH nito, okay, take the absolute value na lang para hindi nakakalito. The change in pH, dapat maliit lang. So, it should be 1 or less. Or, dapat nga less than 1. Dapat less than 1 pag buffer. Okay? 5 and 6, of course, as a buffer system, you expect the delta pH to be small as well. So, ito yung importante dito. Yung small value ng delta pH. Okay? So, ano pa? Yung sa mga odd, nag-add kayo ng acid, sa even, nag-add kayo ng base. Okay? So yan, try to calculate yung mga nandito, no? May calculations para ma-solve nyo yung umulit actually eh. Pero, I'm going to get problems from here or probably make new ones. So, please read on the experiment itself. Okay? Do you have any questions? Okay.